Waiting for mortgage rates to drop could be a costly mistake. Once rates drop, new home buyers will enter the market and prices will soar even higher. At Churchill Mortgage, you can get a free analysis and learn how to avoid the trap of waiting for interest rates to drop. Buy now and refi later at churchillmortgage.com. This is a paid advertisement. NMLS ID 1591. NMLS ConsumerAccess.org. Equal Housing Lender. 1749 Mallory Lane, Suite 100, Brentwood, Tennessee 37027.
Hi there, Andrew Dunkley here, host of Space Nuts, where we talk astronomy and space science every week. This is episode 374. Coming up, we're going to be looking at Bennu. Bennu. No, not Benno, you cricketing tragics. It's Bennu, the asteroid. They brought back dirt and they've examined it and they've determined that it is indeed dirt. No, we'll find out all about what they've discovered from the samples. It's very exciting. And some more on the search for Planet 9. We will investigate that as well. Mikey wants to know about magnetism. Ralph wants to know about nothingness. And Martin has sent us a silly question, which Martin never does, but we'll answer it anyway. That's all coming up on this episode of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And joining us to talk about all of that and to explain why on earth we need macrame is Professor Fred Watson, astronomer at large. Hello, Fred.
Hello, Andrew. Well, macrame's always been something of interest to me, so I'm sure we all feel the same about it and definitely need macrame.
I do not.
There you go.
Well,
is that the end of the show then?
Might be. Could be after that joke. Yeah, absolutely. You're looking very dapper, Fred.
Thank you. It's purely because there's been a couple of TV segments this morning, and I tend to try and look half human when I'm on TV.
Well, it's nice to see you've broken down the barrier of getting on TV because, face for radio comes to mind. But I didn't say
well, that's right. Absolutely. No, I've known that all along.
I've certainly got one.
Yeah, me too. And there are certain certain TV stations who will never have me on. Too ugly.
Isn't that terrible?
The ones that will have me on don't seem to care. So that's
so pretentious in television.
Yeah,
I sat in on a TV show once when we were in New York. The show shall remain nameless, but. It was one of the late night talk shows, and we got ourselves into the audience. You actually had to rehearse to get on as an audience member.
Wow.
I know.
Oh.
And you had to be interviewed, and they had to. I knew what they were doing, so I said to Judy, "Just leave it to me." And I acted like a real pork chop. And she said, "Why did you do that?" I said, "Because we'll get in," and we did. But I found the whole thing so egomaniacal. It just I was gobsmacked at how great they thought they were.
That's television to a T,
and that was off camera.
Yeah. No, it's a different arena from the sort of stuff that you and I know and love. And once in a while I get asked on, but I know it's with reluctance by the people who haven't been able to find anybody else to talk about what it is.
I'm sure that's not true, Fred. I'm sure that's not true.
Anyway.
All right, let's get into it because we've got a lot to talk about. And this first story has broken recently, and it's sort of changed our focus for this episode because the samples that have been returned to Earth in the last few weeks from an asteroid have now been, not totally analysed. They're still analysing them in their secret room in NASA. It's a clean room, as I understand it.
It's a very clean room.
Yeah, it's the Bennu sample, and they've found some intriguing things already.
Yeah, indeed. The great thing about this story, Andrew, is that this is absolutely just the tip of the beginning, because it's not even the proper sample that they've opened up. They haven't opened the sample yet.
Oh.
So what?
This is just the dust on the outside.
It's just the stuff, the dirt on the outside. That's right.
Wow.
So, yes, you're quite right.
You're sure someone didn't drop it in the desert?
they can tell it's a different colour, the desert does. So, as you said, the capsule containing this sample landed on Earth, I think it was the 24th of September. It was around about that time anyway. And after a mission lasting 6 years, in fact, is that right? No, 7 years. It was launched in 2016.
Big.
Went to Bennu, hung around there for quite a while, chose a nice place to drop the sample collector on, and picked up the sample and then came back to Earth. So there's a device on Osiris-Rex, the spacecraft that did all this, which rejoices in the name of the TAGSAM.
The what?
A TAGSAM. You don't know what a TAGSAM is? It's an acronym for the Touch and Go Sample Acquisition Mechanism.
Of course. Why didn't I know that?
So that kind of explains the way it worked. The spacecraft kind of dunked itself into the soil and grabbed a sample, touch and go, and then went. And surprised itself actually by how far it sunk in, because the regolith, the soil of asteroid Bennu, is very loose. It's basically a rubble pile asteroid, which things you.
I heard it got too much and they couldn't get the lid on.
Yeah, that's right. They struggled to get the lid back on, and so this stuff that has now been analysed is just the debris that was left on the TAGSAM after they managed to get the lid closed. So they haven't really opened the main sample yet. So they still don't know how much they've collected, but they think it's a quarter of a kilogram, 200 grams, which, since the mission target was to bring back 60 grams, is pretty good. They think they're onto a bit of a winner with the amount of material that they've brought back. So that sample of dirt around the lid has already revealed some really interesting aspects. For example, lots of carbon-containing compounds, which haven't yet been properly identified. All we know is that there's a lot of carbon there. And that's in some ways not surprising, because Bennu is a carbonaceous asteroid, a carbon-rich asteroid. But to find a lot of carbon in a small sample is very intriguing. So we expect that when the analysis continues, we might find some of these interesting precursors of life and that sort of thing that might be among the soil samples. Also, water-bearing clays have been found.
Yeah, I read that and I thought, wow. The word clay kind of threw me.
Yeah, because you usually think of clay as starting off as mud, and I think the term is just used for minerals that bear water in their crystalline structure, and that's what's been found. And I think what's going to be really interesting when we do get to the nitty-gritty of these samples is to look at that water and, go to that hoary old question of the isotope ratio in the water, whether you're talking about what sort of mixture of heavy water and normal water you're talking about.
Is it the same as what we've got?
Is it the same as what we've got? Exactly. So that's going to be something very intriguing, I think, when we start hearing the results from the main sample. It's all excitement. The testing is going on at the Johnson Space Flight Center, which is where the capsule is now. I think you and I might have mentioned before, maybe we didn't, but Osiris-Rex itself is not done yet. It's heading off in the direction of another asteroid, which is a famous one called Apophis. And it's famous because we will have
a great name too.
Yeah, great name. We'll have a close approach in 2029. At one time it was thought that there might be an impact in 2029, but that we now know won't happen. But I think the one that is one to watch out for is if I remember rightly, a close approach in 2182, by which time you and I will be hundreds of years old.
Yes. But we'll still have space nuts.
Yeah, I'm sure we will. We haven't been able to get rid of it yet. So
we might even get the audience up to 3 by then.
Yeah. None of whom are related to us. Yeah, that would be fantastic.
Yes.
Anyway,
it's is this the only sample Osiris-Rex is going to be able to send back, given it's got an ongoing mission? But
so the Apophis,
this was the only planned return mission, wasn't it?
That's correct. So the Apophis mission is it may be an orbital thing, but it might just be a flyby as well. I'm not sure of the details of that, which is...
It might be going too fast.
That's the issue, yeah.
Yeah.
It's going too fast. You're not going to get it into orbit.
No. With these sample returns, and we've seen a couple this year now or in recent years, are they going to collaborate and do some comparisons to see what the differences might be?
Definitely. So
if they're exactly the same, they could be exactly the same.
Yeah. Ryugu is the other.
That's the one.
Asteroid, which the Japanese Space Agency returned samples of. Was it the end of last year? I can't remember. Sometime round about then, which again are being analysed. It'd be worth checking if you wouldn't mind. So that
how did you know I was doing that?
Because your face lit up as you clicked on your screen.
Right.
Bits of it have gone blue, actually, Andrew. That means you must be looking at something blue. In fact,
I'm still trying to get used to the atmosphere of this new
house,
office of mine.
New office. Yeah.
It was Hayabusa 2, wasn't it?
Yes, that's correct. That's right.
Yeah. Arrived at Ryugu on the 27th of June, 2018, and returned. You better keep talking and I'll keep looking.
Landed in Woomera, didn't it? And is that right? Am I mixing my things up?
5th of December, 2020.
Oh, 2020. Okay. All right.
Yeah. Time flies.
The years pass so quickly these days. Yes. Anyway, that's. I kind of had December in my mind. So there are results from that, but I think Ryugu and Bennu, while they do share the fact that they're both rubble pile asteroids and have got this curious shape of like two cones stuck together by their bases, a bit like the old humming tops that kids used to have when they were a youngster. As you say, what will be really interesting will be comparing and contrasting the analyses of what's in these asteroids.
And of course, last week we talked about the Psyche mission.
Yeah.
I don't remember if I asked you if that was a sample return mission or just an orbital scan.
It's orbital. Yeah. As I understand, there will be no lander. That it's just an orbital mission.
Oh, yeah, we did talk about that. But will they still be able to glean information to compare with the other asteroid visits?
Yes. I mean, it's
because it's a metallic one.
Yeah, indeed. It's made of metal, probably iron mostly.
Solder, probably.
Well, that would have to have tin in it, and maybe could be solder. Yeah, blubber solder. That would certainly set the cat among the pigeons.
It would, wouldn't it? A leftover daub from an exploding spaceship.
Yes, that's right. Especially if it had some of that resin that you used to have to use with salt to make it run. Anyway, we're now engaging in the
off track as usual.
A fantasy from 50 years ago when we both used to wield soldering irons, I'm sure. But so comparing the two will be good. And the Psyche mission will also add its own comparisons to that because they'll use remote sensing of the surface to really analyse what's going on down there. Much the same way as we see, remote sensing on Mars with both orbital spacecraft and good old Perseverance and Curiosity there with
I suppose in time we'll have made probably so many visits to asteroids, we will be able to paint a very solid picture of what's going on and what it means to us as a planet with life on it. What was that the seed that created us? That sort of thing.
That's right. We'll get solid results even from the rubble piles. Yeah. But sorry, I couldn't resist that. It's right. We'll have a much more cogent catalogue of the behaviour of asteroids and the structure of asteroids and all of that sort of thing. So I think we're living in an era of sort of golden age of asteroid studies. When I did my master's degree, the research for that was on asteroid orbits, and I think I was probably the only research student in the entire country who was working on asteroids. Everybody else was doing far more glamorous things because they were so boring. Asteroids, they were just all, they were just things that we didn't know anything about. They floated around, and that was the end of it pretty well. Now it's a thriving industry, mainly because we know that the discoveries made since the days I was working on this stuff. One of them is that we've been clobbered by asteroids in the past, and that's a very important thing.
Yes, we need to learn all about them. We need to keep an eye on them, and we may well learn how we got here because of them, perhaps.
Yeah. Yep.
All these things are intriguing. So you were on the right track from the start, Fred.
I was ahead of my time, but I didn't realise it, as usual.
Absolutely. All right, and obviously we will learn more as they start digging into the samples from Bennu. I did it. I said Bennu. Richie. It's not Richie Bennu. It's just Bennu. People in America are going, what? Who is this Richie Bennu fellow? Look it up. He's one of the greatest Australians that ever lived, in my humble opinion. This is Space Nuts. Andrew Dunkley here with Professor Fred Watson.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
Now, Fred, we move on to another great mystery of the universe. In fact, it's not even that. It's a great mystery of our solar system, and that of Planet 9. Now, we've had a few discussions about it lately because there are attempts to find it. There's something out there. The mathematics says so. Whether or not it's a planet or some other force of nature. But something else has popped up in the news, which has thickened the plot a little bit.
Yes, it has. That's right. The plot thickens, and it's all about plotting orbits. That's where it comes from. So, what? Let's just recap. The backstory is that there are alignments of the orbits of what are called extreme TNOs, extreme trans-Neptunian objects, out in the distant solar system. Their orbits which are very elongated, seem to line up. And back in, I think it was 2016, a couple of scientists in California, I think, postulated that this was because there is a distant massive planet out there in the depths of the solar system that's actually having a gravitational pull on these asteroids. And so that object was called Planet 9, that hypothetical object. It upset some people who still believe that there already is a Planet 9 called Pluto, but that argument's probably died down a bit now. And so the search has been on. We can kind of get a rough idea of where it might be by the alignment of the objects. And the trouble is it turns out to be in the middle of the Milky Way, so it's very difficult to find something faint and moving very slowly. But there are still observational programs which are doing that. Now, there's been a couple of times when people have poured cold water on this idea, and you and I have certainly spoken about one of them, which was the notion that those alignments are not real, that it's all caused by the fact that we can only see the brightest and biggest of these asteroids. If you could see them all, that clustering of the asteroid orbit alignment would disappear. There was a really very well argued paper on that. I think it was probably last year, which you and I talked about. But now something else has come up that suggests that the effect might disappear, and it comes from 2 scientists. Both theoretical physicists, one at Case Western Reserve University and the other at Hamilton College in the United States. And what they've done is they've looked at how our Milky Way galaxy would behave in terms of its gravity if the MOND theory was correct. Now, MOND, you will remember, is modified Newtonian dynamics, and it's a theory that says that at very, very low accelerations, Newton's formulae don't work. When you've got very low accelerations, it's not, you don't see the same thing as you do with forces accelerating objects in our day-to-day world.
Is this a Mondan theory, Fred?
It's not actually that Mondan, because it was published in 1983 1903 or thereabouts, if I remember rightly, by a man called Mordechai Milgrom, who I think was at Tel Aviv, and it became known as MOND. And it's one of the, if I can put it this way, one of the main competitors to dark matter theory. Because the reason why MOND was developed by Mordechai Milgrom was because nobody could find dark matter particles, even though, our best understanding of the way galaxies behave and gravitational lensing goes and all of these things is that there is something out there which has mass, but nothing else. It acts gravitationally, but doesn't interact in any other way with normal subatomic particles. So we can't see it. We can't see its shadow. We can't see anything about it, except that we know that it has gravity and is affecting the way galaxies work. So that's the conventional view of dark matter. But the Milgrom theory says, well, this is daft. There's something that we believe is there and we can't see it. So maybe something else is wrong. And sure enough, if you tweak Newton's laws in the right direction, you can actually get rid of the need for dark matter under some circumstances. It doesn't work for everything. That's the interesting bit. Anyway, it does work for some circumstances. And we have a listener and a good fan of the program, I hope he still is, Peter Verweyen, who's doing his PhD on MOND with the University of Sydney. So occasionally I talk to him and get and see what the latest results are. Anyway, to cut back to Planet 9, what these two physicists have done is said, okay, supposing MOND is real, the modified Newtonian dynamics is the way things are, then what happens to the gravity of our own galaxy in the way that it interacts with objects way out in the depths of the solar system? Would it cause an alignment, is the question. And what happens is it does. So they've found that these alignments, if you assume that these trans-Neptunian objects are interacting not just with the sun's gravitational field, but with the gravitational field of the galaxy as a whole, which is so weak compared with the sun that it actually has this modified Newtonian dynamics. It means normal physics don't work. What they're saying is that there would be a sort of dragging of the orbits of these outer solar system objects to align with our galaxy's gravitational field. And apparently what you get is exactly the alignment that we see if you do the theory of this. It's really a very interesting result and really quite stimulating is probably the wrong word. Just intriguing, perhaps, is the best word.
So, forgive my lack of concentration, but does this mean that they
you really were asleep?
Well, it just prompted a question that was formulating. But does this mean that they're backing the existence of Planet 9 or backing the existence of something that might be not Planet 9?
Yeah, they're backing the existence of not Planet 9 and not dark matter.
Something else.
Yeah, MOND, the modified Newtonian dynamics. They're saying with...
okay.
Yeah, if modified Newtonian dynamics is right, then this alignment happens. That's what they're saying. So you can forget about Planet 9 because you don't need it. And also, it's just another little hint that maybe we're wrong about dark matter, that maybe MOND is the way to go. Very intriguing.
Sorry, is it possible, Fred, that what they've found is real, that Planet 9 could still be real, that dark matter could still be real? Could we be looking at different factors that exist under circumstances unique to themselves? So all of these things could exist or coexist.
Right. Sorry, yes, I see what you mean. So that they could all be right. I guess that's true.
Under different circumstances.
Yeah, maybe even under the same circumstances.
Well, yeah.
Look, you're quite right. And I mean, people, I guess MOND is the main motivation of the people who study MOND is to get rid of dark matter. In other words, eliminate the need for dark matter because we've got something wrong with our understanding of gravity. That's what they're saying, or the way gravity interacts with objects. But the trouble with MOND is, as far as I understand it, you can't get rid of it entirely you can't get rid of dark matter entirely because you've still got the effects of gravitational lensing, which really are independent of MOND, the Newtonian dynamics. That's very much an Einsteinian relativistic thing and behaves exactly as we would expect if dark matter is what is there, if the dark matter theory is correct. So it's really intriguing stuff, I think. And I thought this paper was quite remarkable that, we've got, they've written a paper called Modified Newtonian Dynamics as an Alternative to the Planet 9 Hypothesis. That's pretty striking stuff.
Well, I suppose I can't help but ask you, Fred, where do you stand on the MOND theory? What do you think it's potentially correct?
I think it's very intriguing, and I think there are results coming out that sort of lean you towards thinking, well, there might be something this after all. But the issue is always, and this is what threw MOND out right at the beginning in the 80s when it was proposed, if you accept that for some of the phenomena that we blame dark matter for, like galaxies not flying apart because they're rotating too fast, if that's due to MOND and not dark matter, then it throws other things out that we think we understand in terms of dark matter. And that's the problem. You have to build something that is consistent across all scales. And MOND doesn't seem to do that. On the other hand, we still haven't found any particles, notwithstanding our talk about dark photons the other day. We still haven't found any particles that might actually be dark matter particles. And the particle physicists are struggling to do that.
Could we just have it all wrong completely and there's something else going on that we just have no comprehension of at the moment?
Yeah, that's right. Well, that's always the case in astronomy. We might be looking
You're always wrong.
Yeah, well, you always could be wrong because you can't go out there and poke things in the eye and find out what they're really like. So I think astronomers generally tend to be pretty open-minded about various hypotheses. But yes, it is the consensus of opinion that leads us to believe in things like dark matter. Certainly the bulk of opinion still would support that. But it's in many ways really interesting to see it being, in a sense, chipped away at by people who have a different worldview. The trouble is that it is possible, despite the open-mindedness of most astronomers, it is possible for people to get obsessed with that kind of thing and try and bend everything to fit their worldview. I used to work for somebody like that who had an unconventional view of our galaxy and spent a lot of time tinkering around the edges of what we knew to try and make everything fit together.
Yeah.
So
pretty hard to do.
It is, yeah.
All right. If you'd like to read that article about the MOND theory and the hunt for Planet 9, it's on the Space Daily website. This is Space Nuts with Andrew Dunkley and Fred Watson.
Roger, you're loud and clear here also.
Space Nuts.
Time for some questions, Fred, and we're going to get straight into it. Our first one comes from, he's a semi-regular. This is Mikey.
Hey, Fred. Hey, Andrew. This is Mikey from Illinois. I got a question. A couple episodes back, you guys were talking about magnetism with the sun. Obviously, there's magnetism there. That's why we get sunspots, yada, yada. There's magnetic fields around certain planets, and it got me thinking, if gravity wasn't the major player in the universe, would magnetism be the attractive force? Is there enough magnetism, say, that metallic objects like satellites and certain rocks and asteroids, would they be pulled in by the magnetism and the gravity just supersedes that, and that's why we don't see that now? Just kind of an out there question that I had, kind of stirring up in my head. Thanks, guys. Appreciate everything you do. Have a good one.
Thank you, Mikey. It's an intriguing thought. And we did talk recently about a big magnetic discovery, I think, didn't we, Fred? Somewhere beyond our galaxy or something. But
that's right. It was the biggest magnetic field, or the earliest magnetic field that's been detected. The earliest magnetic field. That's right.
So basically, saying, could magnetism do
replace gravity?
Yeah, replace gravity.
Yeah. No.
Thanks, Mikey. And our next.
But Mikey's, I think Mikey's, it's great thinking. So the gravitational force is many billions of times weaker than the electromagnetic force, which does carry magnetism. So that it's an intriguing thought as to whether a universe without gravity would do anything, would form at all. And part of the problem here is that we don't really understand the origin of magnetic fields. That's
I would have thought it would be a magnet, but anyway.
All right, okay, I'll rephrase it. We don't know where magnets come from. You might think you buy you get them in Kmart, but Walmart, yeah, that's right. So we don't really understand the origin of magnetism or magnetic fields or magnets in the universe, and so we know gravity was always the really strong motivating force for evolution within the universe. It's what pulls clouds of hydrogen together to make stars and make galaxies. That would not happen with magnetism. Even if we understood how magnetism formed, it's kind of almost like a chicken and egg question. If you had a universe with no gravity, would the electromagnetic force replace it, and we'd end up with an entirely different kind of universe from what we've got, maybe without galaxies in it, but with something else. Mike is right to propose a question like that. It's a fun thing to think about. I don't know the answer to it, but I think...
Except no.
I did say no, yeah. And I think the answer is no. I think what you'd form would be something so unlike our universe that it really wouldn't, it just wouldn't bear any relationship to what we understand as reality.
Yeah.
On the other hand, if there were inhabitants in such a universe talking about this sort of thing, they might say the same thing.
Someone comes up with a theory. What if there was a thing called gravity?
Yeah.
Would that do the same thing as magnetism's doing here?
Yeah, and they'd all fall about laughing. They just say, oh, no.
Well, maybe not, because if they didn't have gravity, they might not fall.
But on the other hand, if they didn't have gravity, they wouldn't take anything seriously either. So that would be pretty good.
Oh, dear. Too many dad jokes. Actually, you mentioned the chicken and the egg theory. Yes. I heard one the other day, which some people might know about. I ordered a chicken and an egg from Amazon. I'll let you know.
I like that.
Yeah, it's pretty good.
Yeah,
pretty clever. So, Mikey, the answer is no, but.
Yeah.
We get a lot of no but answers to questions.
We do. Oh, yes, in fact, for that. But yes, it's great question. And, I think magnetism, until very recently, was the sort of least understood of all the universe's attributes. I think we're chipping away at it. And just as a postscript, one of the main pillars of the science case for building the Square Kilometre Array Observatory was to understand the origin of magnetism. So there's a good chance that, by this time in the next decade, we might know a little bit more about that.
Yeah.
Able to talk about it.
It's so much fun to play with, a magnet with iron filings and doing all that stuff through your desk and making compasses out of needles, shove through corks, drop them in the water and they'll point north. Except, important safety tip, do not leave the needle stuck in the carpet pointing straight up and then lean on it like I did when I was a kid. Went straight through my hand.
Oh, God.
Yeah, and it was the eye end that went through. It wasn't the point. Oh, yeah. Didn't bleed. That was really weird.
No.
Anyway. Thank you, Mikey. Lovely to hear from you. Our next question is about nothing. It's from Seinfeld.
Hello, Big Nuts. This is Ralph in Northern California again. Cleaning out my garage today, and I am overwhelmed with the amount of stuff I have. And it occurred to me, when we're talking about space and astronomy and all that, we're always talking about stuff. We're talking about substance. We're talking about tangible things. But as Fred's mentioned in his book before about the vast bulk of our universe is nothing. It's nothingness. It's kind of like that Seinfeld episode. It's all about nothing. Very stray molecules here and there. Can we expand on that a little bit? Is there anything else about nothingness that really is like 42, the secret of the universe, other than dark energy, of course, and stuff like that? It just occurred to me that we always talk about something, but maybe we should talk about nothing. That's question one. Question two is, what does Dr. Watson think about the realistic option of living underground on Mars or the moon, under the surface? Because obviously, as Andrew had pointed out, that old For All Mankind episode where there was a solar bombardment on the moon, things got really janky fast. Anyway, thanks, guys. Keep it up. Love the show. Bye.
Thanks, Ralph. Love the word janky.
Yeah,
that's a
great.
Very good description.
I like that.
Let's start with nothing, and now we can move straight on to living under. Nothingness theory. Should we be talking about nothing? Jerry Seinfeld made a career out of it.
Exactly, and so have we. So, yes, the mantra for the origin of the universe: in the beginning there was nothing, then it exploded. And so, and I think in that regard, the nothing that we think of is so nothingness. There's no time or space. It's just nothing. And I think that is the ultimate nothing, out of which the Big Bang came by some mechanism that we don't understand. That's the sort of standard relativistic picture of the origin of the universe, which might not necessarily tie in with people's idea of multiverses and things like that. It's like Roger Penrose's exploding black holes and things of that sort. However, we do, if you take out all the matter in the universe,
it doesn't matter.
Space, no, it doesn't matter. No, it probably matters more to me than to you. No, can't do anything with that. So, space itself has got funny properties. We know it bends, which is how we see gravitational lensing, by the bending of space. Yeah. We know that that it has an electromagnetic force. There's the thing called the Casimir effect, that two plates kind of feel a pull between them. Mm-hmm. What's that all about if you've got nothing there? And then there's dark energy, exactly as Ralph mentioned. Dark energy is something that comes out of nothing but has an energy, and its energy is so much that for every cubic meter of empty space, it's trying to push it apart with basically a force proportional to its volume. So that doesn't really get us any nearer to a definition of nothing. I think the best definition of nothing is what there was before the Big Bang. So there's no time, there's no space, there was no matter, there was no Walmart.
Yeah,
there was nothing.
No speeding fines.
No space nuts.
No, nothing. So, yeah, we can't say there's nothing. And even in past episodes where we've talked about subatomic particles existing, even in the deepest, darkest vacuum of space, there's something per square meter. It's just not much.
Yeah. No, well, that's certainly right. It is. You're talking about handfuls of atoms and subatomic particles. I mean, the whole universe is permeated by light as well. Wherever you are in the universe, there's going to be light passing through it, or electromagnetic radiation. So that's in there as well. You've got a bundle of photons. Not many, perhaps, but you've certainly got them.
So, Ralph, yeah, there's something. In some places, very, very concentrated. In other places, very sparse. But there is just about something in every square metre of the universe, we think. So, yes, talking about nothing would have been faster, but well, it's probably there's probably more to talk about than nothing.
Yeah, I think Ralph's starting point about cleaning out his garage, that was...
Yeah, I can't believe he did it. Why would he do that?
Definitely something. Well, we had to do ours recently because
me too.
Dug big holes in it, and you've got a new one. So, yeah. Anyway, thanks, Ralph.
All right, and he wanted to know about living underground, Mars
underground,
and the Moon, which I think is ideal. And he referred to the episode of For All Mankind, where they were all up on the surface of the Moon playing hockey or something. And there was a massive bombardment from the sun, and they were exposed to radiation, and they all had to get underground fast, or in at least into some sort of protected environment. And that sort of gleaned into future episodes and future series or future seasons of the show. Living underground seems ideal. You just got to find the place to do it.
Well, there are lava tubes, both on Mars and on the Moon. And I agree with you, actually. I think it makes a lot of sense to find something that's going to give you some protection from solar radiation and solar flares and things of that sort.
So, yes, and they could actually make them quite habitable with the technology we've got. You probably need to build something within the tube that is comfortable. But what you're aiming for is the protection from that exposure in open space that you don't get on Earth from the magnetic field.
Quite so. So you're replacing the magnetic field with solid rock.
Yes, pretty good. All right, Ralph, hopefully that covered that. But living underground seems like the optimal idea. It's just probably a lot colder, I would imagine. Now, finally, a silly question from Martin, because I can't remember what he wanted to talk about.
Hello, Space Nuts. Martin Berman Gorvine of Potomac, Maryland, USA here, writer extraordinaire in many genres, with a silly question that I must ask because I checked with the Universe Splitter app and it said I should ask you a silly question rather than a serious one. So in this universe, my question is elaborating on my recent scenario. Let's say a trillionaire, whom we'll call Egon Russ, were to turn the planet Venus into a black hole and shoot it in the direction of Mars with the very stupid goal of turning Mars into a planet with the rough mass of Earth so that it could have an Earth-like atmosphere and become habitable. Could we avoid utter destruction here on Earth, assuming we were on the opposite side of the sun from these fun and games? Or would we be doomed anyway? Can't wait for the answer. Berman Gorvine, over and out. And
You're such a card, Martin. So what do you want to do? Drag a black hole to create a livable Venus?
No. You've got to turn Venus into a black hole. So it's got to collapse on itself to form an Earth mass black hole, which, if I remember rightly, has got an event horizon that's 18 millimeters in diameter. I think that's
okay.
Right. And then you fling that at Mars in the hope that Mars will accrete the black hole and somehow produce mass from nowhere, or produce rock from nowhere to become Earth-like, and whether we could survive it by being on the opposite side of the solar system when all this happened.
Well, even if we could, we'd end up back there anyway, wouldn't we?
We would, yeah. And I don't know how I think, the first step one, turning Venus into a black hole, that's quite tricky. I think that you probably would need to impart a lot of energy to do that, more than we've got tied up in either Earth or Mars. And I suppose the question that I would ask is, why would you bother, really?
Yes, indeed. But, the idea of the question came, as he said, from an app called Universe Splitter, which I've just found. It's the quantum decision maker.
Oh, really?
Yeah, it's got very high ratings as well. But in one universe, I will now take a chance. In the other universe, I will now play it safe. And you just make a choice.
Uh-huh.
And it could send you off in all sorts of weird directions. Don't know much about it, but it looks like fun.
When you've checked it out, let me know.
Looks like Martin certainly uses that. I guess that one's probably way too far-fetched to really contemplate.
Well, I think Martin was looking for a silly answer, which I haven't really given him yet. Maybe,
I know, 42.
No, I think actually in this case it's not 42. I think the answer is Tuesday. So, or it could be lemonade. Look, it could be anything, really.
Yeah, or it could prompt more questions like, why is a duck?
Yes, why is a duck? And isn't it so? By the way, I don't think we've ever discussed my theory of where Douglas Adams got 42 from.
Oh, no.
Oh.
And have you got time?
Yeah, we have, because it only takes a minute. 42 degrees is the radius of a rainbow.
Oh, you reckon that's where he plucked it from?
Bet it is, yeah. Bet it's the 42 degrees of the radius of the star. It's when you look at a rainbow, you're seeing a circle of colour which is centred on what we call the subsolar point or the anti-solar point. It's the point in the opposite direction to the sun. That's the centre of the circle. The sun's directly behind you, and in a straight line between the sun, you, and this point, that's the centre of the rainbow. But the diameter of a primary bow is 42 degrees.
Well, how about that? Yeah, you may well be right. We will never know.
Probably not. Probably know it.
Okay. Thank you, Martin. Thank you, Ralph. Thank you, Mikey. And keep those questions coming in, because we've got an all questions episode next week. Episode 375. We've got plenty of them, but we don't want you to stop, because we do run out rather quickly. So keep the questions coming. You can do that on our website, spacenutspodcast.com or spacenuts.io, and send a text question via the AMA app, or an audio question, as long as you've got a device with a microphone. And on the right-hand side of our website, it's got a little doohickey that you can press that says, send us your question. And you can record it there. Quite simple. Don't forget to tell us who you are and where you're from. We just love to know. And while you're fishing around on our website, let us know if you find any problems. No, I'd rather you go to the shop, actually. We don't care about problems. Can't solve any anyway. So, yes, there's a Space Nuts shop and all sorts of other stuff. You can get the latest Astronomy Daily news and plenty more. So jump on our website for more information and to upload your questions. Fred, we are done and dusted for another week. Thank you so much.
You're very welcome, Andrew.
Hello, Big Nuts. This is Ralph.
Oops, sorry, wrong button. Try that again.
Yes, you're very welcome, Big Nut, Andrew.
Yeah, I've completely botched this up, so I'm going to have to... Okay, I've stopped him now. Thanks, Ralph. Can't keep him out of it.
Can't. That's
so
right.
Thank you, Fred. It's a pleasure as always.
It's also a pleasure to sit here wondering what's going to happen next.
You never know with me. Yeah. Like I said, the microphone's in a very awkward position and I can't really see what I'm doing, and that's probably why that happened.
Be it.
It just sort of washes away the facade of professionalism, really. Thank you, Fred. I'll see you next week.
Sounds good. Thanks, Andrew. Take care.
Fred Watson, astronomer at large, part of the team here at Space Nuts, and Hugh in the studio. I just turned up. Sorry, Hugh, we just finished. And from me, Andrew Dunkley, thanks for your company. Catch you on the very next episode of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com. This has been another quality podcast production from Bytes.com.